Hi, I'm MOV010, and today I'll be talking about car engine efficiency. So the overview of the presentation, I'll be talking about the background, current engines, gas and diesel engines, thermodynamics, a little bit of thermodynamics, how to calculate efficiency, and wrap it up. So the first internal combustion engine actually didn't have the compression stroke, and it was in 1806, the first internal combustion engine was actually fueled by hydrogen, and then it wasn't until 1862 when Nicholas Otto designed an internal combustion engine with a greater efficiency. As you can see in the picture, that's the one Mr. Marcus had used attached a gas engine to a handcart to make the first car. Today's engine, the smallest engine and largest engine by volume is the Tata Nano and Dodge Viper. The fastest engine is the Koenigsegg Agera, and then the most powerful engine is Bugatti Chiron, putting out about 1,500 horses. So internal combustion engines. So it's a four-stroke engine. So for the first part, it draws in air as the piston goes down, and then compresses the air as the piston comes back up, and mixes with the air and fuel, and the spark plug is used to combust the mixture. Well, pushing the piston back down to turn the crankshaft, and then piston goes back down, comes back up, releasing the combustion exhaust out. Diesel engines work similarly, but as Brennan had said earlier, they don't have a spark plug, but they use highly compressed air to ignite it and have fuel injectors. Basically, they work the same way or similarly to gas engine. So here's the ideal and real Otto cycle. So from steps 1 to 2, it's draws in air and increasing the pressure and temperature, goes through adiabatic compression. And then from 2 to 3 is where heat is absorbed at constant volume, and at step 3 is where the combustion occurs, increasing the temperature. And then from 3 to 4 is where the adiabatic compression occurs, and from 4 to 1 is where heat is rejected and the exhaust exits, increasing the temperature. So calculated efficiency is work over heat input. It can be reduced to the bottom equation right here to calculate efficiency. So turbochargers and superchargers, I myself was actually quite confused, and I feel like some people are confused whenever they hear turbochargers and superchargers. They're the same thing. They're not. So turbochargers uses the exhaust stream from the engine, and it drives a turbine compressing the air, while a supercharger is directly connected to the engine and compresses more air than the displacement of the engine. Turbochargers work better at higher RPMs, and superchargers work better at lower RPMs. Turbochargers are actually they require less power because it's not connected to the engine, so it's not drawing additional power. But they are highly efficient. Like a lot of cars nowadays have turbos. Like as you can see in the back of the Koenigsegg Agera, it has a twin turbo V8, and then the Bugatti Chiron has a quad turbo. So basically, two twin turbo V8s in it. And superchargers require more power and less efficient. The most efficient engines, on the left, you'll see a turbocharged 2-stroke diesel engine. That's the most powerful and most efficient diesel engine out, and it pushes a ship full of shipping containers. It exceeds 50% thermal efficiency. On the right, you'll see that this is a Toyota 2.0 4-cylinder engine. It's the most thermal efficient 2-liter gas engine. In a conventional car, a conventional gas-powered car, its thermal efficiency is 40%, but in a hybrid, it decreases by 5%. You can find them in the Toyota 68, which is a two-door car, and the WBRC. To wrap this up, basically, which engine is more efficient? It depends, because if you think about it, like diesel, the cost of diesel fuel is higher, but over the life of the car, the diesel engine car and gas engine basically equal out. But depending on, it all depends on the preference and purpose of the user. Depending if you're hauling a payload of about 5 tons, or just hauling a boat behind, you can use the gas. You can use a mid-size pickup truck, or even a like a 3/4 ton diesel engine, diesel truck. And that pretty much concludes my presentation.